Hello friends, let's start with question number 24 in this lecture. A very simple question. Here we have to find value of K given that power dissipated in 2 ohm resistance is 12.5 watt. So from this given information we can easily derive that I square R is the power dissipated. So I square is equal to 12.5 divided by R, that is 2, that is 6.25 I square. So current is equal to under root of 6.25, that is 2.5. Okay, so current through 2 ohm resistance should be 2.5 amperes. Now I will copy this figure. Okay. So I think I will have to add a page here. Okay, so a very simple question. Now we can see that the current through 2 ohm resistance will be V0 by 2, because we can see that voltage drop across this 2 ohm resistance is V0 and resistance is 2 ohms, so current has to be V0 by 2, that is voltage divided by resistance. The current through 10 amperes, that is at this node A, is kV0 and the outgoing current is 5 amperes. So KCL at node A, incoming current is kV0, incoming current is V0 by 2 and outgoing current is 5 amperes. Now, since current through 2 ohm resistance has to be 2.5 amperes, so I can say that V0 by 2 equals to 2.5 amperes and V0 is equals to 5 volts. Okay, right? Now, so is it clear? V0 equals to 5. Now equation number 1, so K into 5 plus 5 by 2 is equals to 5. So K into 5 is equals to 2.5 and K is equals to 0. Okay, so this is the answer. Very simple question. So let's move on to question number 25. Here we have to find the current in amperes. So this is very important, that the unit in which we have to find the answer and across this resistance 1 ohm resistance. Okay, okay, so now we will solve the question. Okay, now, so let us assume that so first of all, let us assume that this is a grounded and this 1 ampere current is coming at this node A. Let us assume that current I1 flows here. So current I1 minus 1 will flow in the left direction. I am applying KCL at this node. Incoming current is 1 ampere. Sorry. Incoming current is 1 ampere. Outgoing to the right is I1 and outgoing to the left will be I minus I1. Okay. Now, again, if I assume that the current coming here is I2, so current in this branch will be I1 plus I2. Okay, so in this branch it is I2 is going outside. Incoming current is 1 minus I1. So the current in this branch will be 1 minus I1 minus I2. Okay, so I have applied KCL at node B also, KCL at node C also. Okay, so I am solving this in this method. Okay, you can use mesh analysis also to solve the question, but this is a simpler method because in mesh analysis, if I assume I1, I2, and I3 in the three loops, then it is very difficult to find out the current in the separate elements. Okay, this is a better method according to me. Okay, so everything is available now. So now I will apply KVL in loop A, B, C, A. Okay, so this is the loop. Okay, A to B, B to C, A to B, B to C, and C to A. Now, A to B, the drop will be plus at right, minus at left, because current is flowing from right to left. So, from A to B, we are entering from positive terminal, so it will be written as plus 1 resistance value multiplied by 1 minus I1, that is current value. Now, from B to C, we are entering at a negative terminal, so it is minus 1. Now in this resistance from C to A, since the current is flowing from left to right, so polarity will be plus at left and minus at right. So when we are moving from C to A, we are entering at minus terminal, so it is minus 1, that is resistance value, and I1, that is the current value, that is 0. Okay. So 1 minus I1 minus 1 minus I1 is equal to 0. These two cancel each other. So I1 is equal to 0. This is the result. Now, another loop equation that we will use, because there are only two variables, so two equations are required. So let's suppose that this is D node. Okay. So KVL in loop C to D, D to B, B to A, then A to C. Okay. Now C to D. Now since the current is flowing from top to bottom, the plus terminal will be at the top, and from moving from C to D, we are moving from plus to minus. So in the loop equation, it will be plus the value of resistance, that is 1, I1 plus I2. Okay. Now from D to B, since current is flowing from top to bottom, plus will be at the top, minus will be at the bottom, as I have already shown here. And while moving from D to B, we are entering the minus terminal, so it is minus resistance value 1 minus I1 minus I2. Moving from B to A, we will encounter minus first, so it will be minus 1 minus I1. From A to C, we will encounter the positive terminal first, so it is plus 1 multiplied by I1, that is equals to 0. Now solving this, I1 is already 0, so I will remove I1. So it is I2 1 minus I2 minus 1 is equal to 0. I will need to add a page here. Okay, so after solving this, I can say that 2I2 is equal to 2, I2 equals to 1. So I1 is 0 and I2 is 1. So I can say that the current that is flowing in a resistance 1 ohm, this resistance is I1 plus I2, that is 1 ohm. Okay, so you got the answer. Okay. So this is a better method according to me. Okay. Now let's move on to the next question. So in this question, it is given that a Y network has resistances of 10 ohm each in two arms, and the third arm has a resistance of 11 ohms. So it is 10, 10 and 11. Now its equivalent pi network, so let us say this is A terminal, B terminal and C terminal. So equivalent pi network will have resistances R1, here it will be R2, and here it will be R3. Okay, now as we know that R1 will be equal to 10 plus 11 plus 10 into 11 divided by 10, because as we have already seen the formulas of converting to from star to delta and delta to star, so we can easily find the value of R1. So R1 will be equal to 10 plus 11, that is 32 ohms. Similarly, R2 will be equal to 10 plus 10 plus 10 into 10 divided by 11, and R3 will be equal to 11 plus 10 plus 11 into 10 divided by 10, that is 32, and this will be equal to 20 plus 100 divided by 11, and we can solve this to get the answer, and we have to give the lowest value of the resistance in ohms. So lowest will be R2, that will be equal to 20 plus 100 divided by 11, and this will be approximately 9.09, and thus the answer will be 20 plus 9.09, that is 29.09 ohms is the lowest value of the resistances. Okay, so few questions are left in this topic, so we will be continuing in the next part of the lecture series. So thank you guys, and keep sharing these lectures and subscribe to the channel.